Empirical formulas, simplest ratio of atoms in a compound. So when you look at chemical formula, chemical compound, you would write the empirical formula from its molecular formula. Generally speaking, a molecular formula is the true formula, or the version where you can calculate all of the different types of atom in the chemical formula. And then once you build your molecular formula, your empirical formula can be obtained by looking at the simplest ratio of the atoms in the compound. For instance, here we have 3 molecular formulas, okay? And I'm going to write the empirical formulas for each by figuring out the simplest ratio of atoms to each other in the formula. Basically, find the smallest and divide them all by the smallest and see if they come out to whole numbers to be simplified. If I divide all these by 6, I'll get C. 1C, 2H is 1O. If I divide these all by 2, I get an HO. And this simplest formula is the same as. So sometimes a molecular formula can be the same as the empirical formula. Now, we're not going to keep it that simple, of course. We're going to learn how to calculate an empirical formula from the amount of mass we have per atom. So this is a poem. I like to call it a poem. Not perfect poem, but we'll call it a poem. Percent to mass, mass to mole, divide by small, multiply to whole. You can think of this as the 4 steps that you'll perform to calculate an empirical formula or to obtain an empirical formula mathematically. Please know that the percent to mass step might be skipped at times, and the multiply to whole step might be skipped. So both can be skipped, or one or the other could be skipped. But we always have to do mass to mole and divide by small. Every single time you have to do mass to mole and divide by small. When my students make mistakes, the most often thing they forget to do is divide them by the small. Okay, so I like to think of this as my sandwich. I have my bread slice, and the meat in the middle. I can never forget the meat, the most important part of the sandwich. Okay, so this is number 1. We have calcium, 20 grams of calcium and 80 grams of bromine. And we're going to calculate the empirical formula. So we're going to think about the poem. The first line of the poem is percent to mass. They're already in mass, so we can skip that step and go to the second step, mass to mole. So now we're on mass to mole. So we're going to take each of the atoms, calcium and bromine, and we're going to take their masses, 20 grams and 80 grams, and we're going to convert them to moles from mass using the periodic table number, or the molar mass. So we're going to do a grid. We know there's 40.08 grams of calcium for every 1 mole of calcium from the periodic table, and there's 79.90 grams of bromine for every 1 mole of bromine from the periodic table. Remember, when you use your molar mass, your opposite number is always 1 mole. So for there, if we multiply the top numbers, divide by the bottom, multiply across top and bottom and divide, same thing, we get this value. Now I am using sig figs here. If you are in the year of 2021 school year, then we will do 4 places past the decimal instead of doing sig figs. So always round 4 places past the decimal, or round at the 4th place past the decimal. So here we have 80 divided by the molar mass, we get 1.00. Again, remember sig figs, if you're in year 2020, 2021, 4 places past the decimal, 4 places past the decimal is the best bet. So then we did that step. Let me go back for just a moment. So we got to mass to mole. We're done with that. Everything is in moles. Now we're going to go to the next step, divide by small. So we're going to look at all of the list. If we had 10 of these, we look at all 10 and find the smallest. So the smallest we know is 4.499 moles of calcium. And we're going to divide them all by the smallest. So all of them, 2 here. If there was 10, we take all 10. All of them get divided by the smallest. So I divide that, I get 1. And I divide this one by the smallest, and I get 2.01. So remember that you need to show units and formulas, as I've modeled here, until you get to divide by small step, and then you can stop using units and formulas. So I get 1 as a ratio and 2.0 as a ratio. Now we're at the multiply to whole step. So we're going to look at the first place past the decimal, or the 10th place for all our values that we just divided by small for. So this one and this one, we're going to look at that first decimal place, and then we're going to decide which of these 2 are true. If all of them have to be either 0, 9, so all of them are 0 and or 9, so they can be 0, 9, 9, 9, 0, 0, 9, 0, 0, 9, whichever, right? If any of them, and any or all of them, I shouldn't say any or, it should be all of them have to be a 0 and or a 9, then I can just round. So this is true, that's a 0, so I can just round, which means I don't have to worry about the multiply to whole, okay, because that's true, this is true, and that is not, so I do not have to multiply to whole. I can instead just round, because I have 1 calcium and 1 1 calcium and 2 bromines. So this step here was skipped because we did not need it, as the numbers were already whole numbers. So once I get my divide by small, I either round. If the first place past the decimal for all are zeros or nines, we can just round them all then. But they all have to be either zeros or nines to round, so basically really close to the next whole number. Or we multiply till whole. Since these were both zeros, I could just make this 1 calcium, because this ends up being a 1 ratio, and round it to 2 bromines. Okay, looking at another example, this is number 11 in your packet. So we have these percentages of carbon, hydrogen, oxygen, and chlorine. So we're going to begin to go through our steps. First thing is percent to mass, and yes, we will need to do that step. Why? Because these are all in percentages. So we're going to say assume 100 grams. That's how we'll take care of the percent to mass. So when we say assume 100 grams, that's the same thing as saying if we have a sample size that's 100 grams, then 35.11% of 100 is 35.11 grams. So assume 100 grams, same thing as saying if we assume that the sample size is 100 grams, then 35.11% out of 100 would be 35.11. So therefore, when we say this, we can turn all of our percents then into gram symbols, like this. Then we're going to the next step, which is mass to mole step. So remember, that's where we're going to take each of the atoms in the compound and take their gram values and divide them by the molar mass for each off the periodic table. That's where I got all these. Okay, and then I'm going to multiply across the top, divide by the bottom, I get these. So that takes care of the mass to mole step. Next step is divide by small, so we're going to evaluate all of these and find the smallest. This is the smallest one. I'm going to divide all of them by the smallest. All of them, so if there's 4 of them, so all 4 get divided by the smallest. And we get these ratios. Now we're going to evaluate the multiply till whole piece. So we're looking at the first decimal place, so I have a first decimal place, or the 10th place, without a 0 or a 9, so I'm going to have to multiply to whole. I cannot round, because one of the first decimal places, so one of the first places past the decimal is not a 0 or a 9, this one right here. Therefore, none of them can be rounded to whole. I have to multiply to whole instead of rounding to whole like we did on the last example. So we're going to first multiply all these by 2. If that doesn't get it, then we're going to go back to these originals and multiply all 4 of these by 3. If that wouldn't get me to that rule of a 0 or a 9 in the 10th place, then I'll go back to and do 4, and I keep doing that until I get to a 0 or a 9 in all 4 of the first decimal places. So we're going to first try 2, and that's what this is talking about. We do see that they're not all, so then we're going to have to multiply till whole, these, because I have a 5 here. Multiply all by 2. When I do that, I get these values. Now we're going to evaluate if the first decimal place, or the 10th place, is a 0 or 9 for all. Yes, 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 and yes. So now I can just round until whole. So it's one of these two. We know it's either they are all 0s or 9s, or they're not. We established that they were. So now from those new numbers, I can write my formula and just round. So C3H8, O2Cl2, C3H8, O2Cl2. That is my final answer.